So this example comes with section 11.2 combinations. In this example, we're asked to simplify this strange-looking expression of n choose 5 divided by n minus 1 choose 3. To even get started with this, you would need to look at a formula sheet or know that n choose r, NCr is equal to n factorial over n minus r factorial, r factorial. That's on your formula sheets. It's not something you really need to have memorized. But so what that lets me do then is say what n choose 5 is. N choose 5 is going to be n factorial over n minus 5 factorial times 5 factorial. Now that's divided by n minus 1 factorial over n minus 1 minus 3 factorial times 3 factorial. Now it looks pretty awful, fraction over a fraction, but if you start to write it a little bit neater and tidier, you can say this is n factorial over n minus 5 factorial times, 5 factorial is just 120, so maybe let's even just do that one. And then dividing by a fraction means multiplying by its reciprocal, so we can put the n minus 1 minus 3 gives me n minus 4 factorial. 3 factorial just equals 6. And we still have n minus 1 factorial here. Besides reducing the 6 over 120, if you don't know how to deal with these factorial notations, you get stuck at that point. What you need to recall is that n factorial just means n times n minus 1 times n minus 2, etc., all the way down to 3 times 2 times 1. n minus 5 factorial is the same idea, but it's n minus 5 times n minus 6 times n minus 7, all the way down to 3 times 2 times 1. Now, n minus 4 factorial is n minus 4 times n minus 5, dot, 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 3, 2, 1. I've got this 6 over 120 factor that I almost forgot here, so maybe let's put it right out in front. We've got a 6 on top and a 120 on the bottom. Right now I'm just focusing on these factorials and saying, well, n minus 1 factorial is n minus 1 times n minus 2, dot, 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 3, 2, 1. Now that's the worst step of the problem because that's the biggest. But if you look and see how much of this cancels out, for example, everything from n minus 1, n minus 2, all the way down to 3, 2, 1 is common on the top and on the bottom. You can cross them out. Everything from n minus 5 down is common from the top and the bottom. And so you're left with that. And so what do we have now? We've got 6 over 120, which is the same thing as 1 over 20, times n minus 4, and much simpler expression than what we had at the top, but equivalent, and we'd be able to use it in further parts of whatever that question was about. So in this second example, we're asked this time not just to simplify, but actually solve. We're given an equation, which means that in the end we should be able to say what n equals. The reasoning or the work involved is essentially the same. We've got 720 times, this is going to be n factorial over n minus 5 factorial times 5 factorial equals n plus 1 factorial over n plus 1 minus 5 factorial. So what can we do with it? Well, first of all, 5 factorial is 120. 720 divided by that just gives me 6. So at least I can deal with the numbers a little bit. Now, n factorial is again n times n minus 1 times n minus 2, dot, 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 times 3, 2, times 1. That divided by n minus 5 times n minus 6 times n minus 7, dot, 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 3 times 2 times 1. So there's my left side. The right side I have n plus 1 factorial. So n plus 1 times n minus 1, all the way down to 3, 2, 1. And finally, this bottom one, n plus 1 minus 5, is the same thing as n minus 4. And so n minus 4 factorial is going to give me n minus 4 times n minus 5, all the way down to 3, 2, 1. So once again, a lot of things are going to simplify here. And since we have an equal sign, as long as we do things to the left side and the right side of the equal sign, we're not breaking any rules. So for example, divide both sides by n. There goes those terms. Divide both sides by n minus 1. There goes those terms. In fact, divide by everything from there down, and you cancel out most of the numerator on both sides. Same thing on the bottom. If I multiply both sides by n minus 5, these n minus 5s will go away. In fact, if I do that with every term from there down, I cancel out everything except for 6 on the left side and n plus 1 over n minus 4 on the right side. So we've broken this thing down into is just a rational equation, something that we would have solved in Chapter 9 and probably in even courses before this, if you were paying attention in Math 20. Multiply both sides by n minus 4, it gives me 6n minus 24 equals n plus 1. So bring all the n's to one side, bring all the numbers to the other side, and I get that n has to equal 5. Very good idea in these questions to check to see if that works back in the original question. And if you try 720 times 5 choose 5 equals 6p5, you'll find that 720 times 1 equals 720, and it does work out. The reason why I say it's a good idea to check in these ones is you will find some extraneous solutions in perms and coms questions where you're asked to solve.